Welcome on next session, and I'm now with Juan Luis Cano Rodríguez, who is a product manager at Quantum Black and AI by McKinsey. And Juan today will answer for us who needs ChatGPT in his presentation, who needs ChatGPT, rock-solid AI pipelines with Hugging Face and Kedro. So Juan, the stage is yours, and I will just only remember for you that you can paste your question on the chat to Juan's presentations. Juan, once again, the stage is yours.
Thank you very much, Mateus. Well, thank you very much, everybody, for joining to this presentation. Who needs ChatGPT, rock-solid AI pipelines with Hugging Face and Kedro? So this is what I want to cover today. So first of all, I'm going to make a real quick introduction to my thoughts on the open models in the ChatGPT era and talk a little bit about open source models versus commercial models. And right after that, I'm going to introduce Kedro, which is a Python framework for maintainable data science and how we can fight spaghetti AI code with it. Then I'm going to do a demo, which is going to be a walkthrough of a Kedro project that performs some ingestion on data and then uses some open AI models to extract some insights from it. And I'm going to jump to the conclusions and open it for Q&A. But before I start, allow me to introduce myself. So my name is Juan Luis. I'm currently a product manager at Quantum Black, which is the AI branch of McKinsey. I'm originally an aerospace engineer and then became a self-taught Pythonista. And I've been in love with the Python community and open source communities in general since more than a decade. So I bring lots of expertise in contributing to upstream open source projects, and I'm currently becoming a Kedro expert. So hope you can join me in this journey. So first of all, despite the clickbaity title, the truth is that we live in the golden age of commercial AI, and there's no shortage of solutions that exist for a huge variety of use cases. So it's never been easier to use AI-powered apps than before. So this is just a screenshot of the recent announcements that OpenAI made in their developer day, and I'm sure there's much more to come in the coming months. But what's also true is that we live in the golden age of open AI as well. I put this star here because the open source initiative is still figuring out what open source means in the context of AI, whether we should consider the weights, the training data, and so on. But suffice to say that for our purposes, we can consider open models those that we can download and use for different purposes. And the amount of models that exist in this case in the Hugging Face platform is just enormous. So you have more than 400,000 models at the moment. And the interesting thing is that these models can be used to perform a large variety of different tasks. So you have models that are focused on computer vision, others that are focused on natural language processing. And if you deep dive into each of the categories, you have, for example, for NLP, things like text classification, summarization, conversational models, so the chat interfaces we've been accustomed to lately, and many more things. But all of these models give a lot of flexibility, but they need to be run and operated, right? So as always with open technology, it requires some expertise and some care to properly operate, and AI models are no exception. In fact, some of these models are huge in size. They have billions or tens of billions of parameters, and they might need some high performance hardware to just produce the results. But beyond that, you will probably also need to put some guardrails and things like that, because otherwise the results of the models can be somewhat unpredictable. So this is the same as building a tall building in a sense. So if we have a proper blueprint and a clear construction plan, then our building will be stable. So similarly, if we apply good software engineering principles to our machine learning and data science codes. But if we do not have a good plan and proper foundations, then we will have something more similar to this, which maybe is good for insights, but the moment you want to run all of these systems in production, things are not going to scale well. And in the end, this leads to all the challenges that we know and love from the data science world and operating these models in production, right? So these are some quotes that we have been extracting over the years from users, clients, and so on. And everybody has a different version of it. So for example, the fact that everybody works in different ways, or that someone else's code will not run in another person's machine, or that there's a lack of standardization in general. So there's no shortage of problems that come with running any sort of machine learning or AI in production. In short, the AI model, whether you're using a commercial API or some of the pre-trained open models that you can download, is only the beginning. And there are many things and lots of infrastructure that you need to run these models in production successfully. So this is why we created Kedro. So Kedro is an open source Python toolbox that helps you apply good software engineering principles to data science code, making it easier to transition from prototype to production. It was created internally at Quantum Black as early as 2017 to consolidate some of the good engineering practices that were already in place. And then later on, we donated it to the Linux Foundation AI and Data. So Kedro started its life as an open source project in 2019, 4 years ago now, and it's been part of LF already for a couple of years. In general, Kedro aims to reduce the time spent rewriting data science experiments so that they are fit to production. It encourages harmonious team collaboration and improves productivity, and aims to upskill collaborators as well on how to apply software engineering principles to data science code. At the moment of this recording, it has almost 9,000 GitHub stars, and it counted almost 500,000 monthly downloads. And according to our telemetry, there were more than 15 million pipeline runs only in 2022. It has been adopted by many companies, large and small. These are just a few of them that are part of our community. And specifically, the technical steering committee of Kedro is made by McKinsey, Claypot, Getting Data, and Societe Generale. So we're making progress towards making it a multi-stakeholder project, and we hope that the community keeps growing and more contributors from other places join us. So this is an overview of what Kedro is in a nutshell. So on the left-hand side, you have a visual representation of a pipeline, which is the most important abstraction in Kedro. And a pipeline will take some data sets as inputs. It will execute some nodes that will themselves produce some other data sets. And this process will go on until some output data set is produced. In the center, you have the catalog, which is the declarative way of specifying all the input and output data sets. So you see, for example, that in this toy example, we're declaring 4 data sets. The first 3 of them are the inputs to our nodes, and then the last one is the final output, which is going to be a train model. As you can see, Kedro supports reading and writing both to file paths on disk, but any other remote file path that is compatible with FSSpec. So if you're using an Amazon S3 bucket or Azure Blob Storage or your database and so on, all of these connection strings are supported. And then finally on the right, you have the definition of the pipeline, which happens in Python. And the pipeline is what links everything together. So the nodes will be the functions, and then these nodes will refer to some inputs and outputs that are directly connected to the catalog. And so the pipeline ties everything by feeding the data sets to the node functions and then recovering the outputs and transforming them into more data sets. So that is the basic functionality of Kedro pipelines, but Kedro offers much more. First of all, when you create a Kedro project, it gives you some options to use standardized project templates. This is inspired originally by the cookie cutter data science, but it offers many more starters these days that allow you to easily bootstrap projects that use Spark or that use MLflow and so on and so forth. And you can also create your own starters. Then the data catalog, which is the declarative layer that I was mentioning, is the one that holds all the parameters, but configuration in Kedro goes well beyond that. So you have the data sets in the catalog, you also have parameters that can affect the behavior of the nodes and the pipelines, and you have credentials as well that can be stored locally, and you can use your custom YAML configuration files for specific purposes. Then the node sub-pipelines are the ones that perform all the computation. We offer an official visualization and experiment tracking tool called Kedro Vis that you can use as well to visualize the pipeline and track your experiments and so on. And all of this can be extended through the use of hooks. So there's a way to connect to the different parts of the Kedro execution runtime, and then you will be able to tweak the behavior, produce some reports, connect Kedro with external tools, and so on. In the end, Kedro covers a wide range of your data and machine learning pipelines execution. So from the ingestion of the raw data to the training and the validation of the model, going through all the cleaning, pre-processing, feature engineering, and so on. And then we encourage users to deploy Kedro to some of the existing orchestrators. So we're aware that the data space is quite complex, and there's a number of tools to choose from. So I'm going to just mention a few of them to understand a little bit how Kedro relates to each one of these. So on one hand, we have things like cookie cutter, for example. It's not really a competitor because Kedro uses cookie cutter under the hood. So it's a way to create the project starter, but Kedro offers much more. And then you have data catalogs such as intake, for example. Intake lots has lots of connectors, but Kedro offers some extra functionality by allowing both read and write, and it connects that tightly with the rest of the ecosystem. Kedro is also often compared with dbt. So dbt started its way as kind of an orchestration tool for SQL transformations and has become extremely successful in the data warehousing space. And it has gained Python support lately as well. However, dbt is mostly concerned with structured data and tabular transformations, and Kedro has connectors with all sorts of data, images, video, and structured data of different sorts, and so on. And then you have MLflow, for example. So in fact, one of our most successful plugins is Kedro MLflow. So lots of users have been using both successfully to execute their experiments with Kedro and then log the results with MLflow. And finally, you have the open source orchestrators such as Airflow, Prefect, Argo, Daxter, and so on. And the truth is that Kedro has connections with many of those orchestrators. So you have, for example, on the right-hand side, the existing connectors and integrations with some of the open source orchestrators. And then on the left-hand side, you have the list of integrations with commercial MLOps platforms. So all the cloud vendors, Amazon, Azure, Databricks, Snowflake, and Google, and also Iguazio, which was a recent acquisition from McKinsey. So in summary, Kedro is a data science development framework, could be considered a machine learning engineering framework or a pipeline framework, but it doesn't aim to be a full stack MLOps framework because that's a very difficult thing to achieve in general. It doesn't aim to be an orchestrator either, so it encourages you to connect Kedro with the existing orchestrators, and in general, it's not going to be a replacement for your data infrastructure. You can learn more about Kedro in different ways. So we have a blog in which we publish different blog posts about technical things that you can do with Kedro, how you can migrate your existing project to Kedro, different connectors, recent activity in the project, and so on. There's a demo project that I'm going to show very briefly that allows you to interact with visualization of a pipeline through Kedro Viz. All our documentation is online and very extensive, so we recommend you to check it out as well. And we have a quite active Slack community in which people are routinely asking questions, sharing knowledge, announcing new plugins and integrations, and so on. So without further ado, I'm going to do a very quick demo. So allow me to share my browser interface. And first of all, if you go to the demo projects, you're going to see an interface like this. So this is how a Kedro pipeline looks from the Kedro Viz perspective. You have the datasets on top, and then you can also see some information about those, for example, the number of rows that it has, columns, and so on. And then if you go down, you see the different ingestion steps. And in fact, as you can see, some of them can be collapsed because you can have namespaced pipelines that group different other steps. And then if you keep scrolling down, then you would go to the outputs of those pipelines. So if those are images or other tables and things like that, you can visualize them here quite easily. So that is how Kedro Viz pipeline looks like. So I'm going to devote some minutes to talk about the use case that I wanted to do for this. So I'm very saddened by the recent developments at Twitter, now X. So I've been spending more and more time on Mastodon. And Luis Villa, which is the co-founder of Tightlift and former director at Wikimedia and a person that I follow a lot, was asking the other day that he would love to have some tool that archives his posts and then uses some sort of large language model to summarize them and publish those conclusions in his blog. So I found that this was a very interesting thing to tackle. And in fact, I asked him whether I could do it, and he confirmed that I could. So I have his full consent to do everything that I'm going to do here. And so I started creating a Kedro project to do that. So this is the repository that contains the code. And just a quick overview of the architecture that we have. So on one hand, we have the ingestion of the data. So I'm going to be using the Mastodon API to load some of these statuses, and I'm going to store them in what I called a local lakehouse. So it's going to be backed by Minio, and I'm using the Delta format, so fully open source technology. And then on that lakehouse, I'm going to perform some transformations using Kedro initially to conduct some pre-processing, filtering, and so on, and also Hugging Face models so that I can extract some insights and so on. So without further ado, I'm going to go to the code and allow me to make a brief tour of how the project looks like. So first of all, this is the catalog. So the catalog contains the datasets, as I was mentioning before, but more broadly, it contains also connectors with anything that is doing input and output. So for example, I have my status table, which is going to be Polar's data frame using the Delta format. If you haven't heard of Polars yet, it's a successor of Pandas, so a new data frame library written in Rust and Python, but the details of that are not important for now. And then I'm going to store that in this S3 sort of API, and internally I'm going to use my MinIO credentials. So this allows me to cleanly separate the access to my system from the declaration of the datasets themselves. To achieve that, Kedro uses the concept of environments. So the base environment is the one that usually I'm going to commit to version control and so on. And then I have the local environment that contains any sort of credentials, tokens, and so on. And this is usually going to be node dependent. And also I'm abstaining from committing it to Git to avoid leaking any potential secrets. So that is the catalog. And then if I go to the pipelines, then you're going to see that basically every Kedro project is a Python library. So we have our pubproject.toml, so the modern alternative to setup.py that allows me to declare all the dependencies of my project and so on. And then I'm storing all my code inside here. And there's a standardized directory structure that Kedro uses to identify where the pipelines are. So if you go to the pipelines directory, you are going to see that I have at the moment 3 pipelines defined. So data cleaning, data extraction, and reporting. And then each of those pipelines does a different thing. So for example, if I go to the data extraction pipeline, then I see that I have a bunch of nodes here, and I'm using, in this case, Pydantic v2 models to validate and extract the JSON data from the Mastodon API and transforming that into a Polar's data frame. But as you can see here, if you focus on this node function, there's no input and output happening here. So the function receives already a list of dictionaries. So someone else has taken care of reading that. And then it produces a Polar's data frame. So then again, someone else is taking care of serializing that. And the way this is done is by using the pipeline. So this data extraction pipeline at this moment doesn't contain any nodes because I did that manually externally. But if you see the data cleaning pipeline, for example, then you can see that it's creating one node using the clean statuses function, and then it's giving that this dataset name as input and declaring this dataset name as output. So the datasets are taking care of all the inputs and the outputs. And then the actual Python objects are being passed to the functions. Okay, so enough about the code. Now we can experiment a little bit on how this all looks like. So I'm going to create a new notebook for demonstration purposes that I'm going to call demo. And then there's a bunch of ways in which I can use all these abstractions locally. So the quickest one is going to use using the Kedro.ipython extension. And then the moment I use this extension on in any IPython compatible interface, can be Jupyter, can be VS Code, both of them work. I'm going to have the Kedro catalog available at my disposal. So I'm going to give this a couple of seconds. There we go. And as you see, if I do catalog.list, for example, then you see that I have here all my data sets, including the parameters and so on. So if I want to load the pre-processed version of the data that I downloaded, then I can do catalog.load statuses clean, and I display the head of that. And as you can see, this is a Polars data frame that contains already some ID, the date, some mentions, and the actual text that I'm using. So now, how do I apply the Hugging Face pre-trained models with this? Well, the good news is that the catalog has also the capability of connecting to said Hugging Face models through a new connector that we introduced recently, which is the Hugging Face Transformer Pipeline datasets. So, for example, here I'm declaring one summarization pipeline that's using this particular model. And I'm also using some sentiment analysis pipelines. You can also use some text generation models and so on and so forth. So to load any of these pipelines here, what you can do is, again, turn to the catalog and do load, and then we're going to load this summarizer model here, summarizer model, and I'm going to call this my summarizer. And this is going to take a few seconds because it's going to need to hold all the weights of the model, but I already have it. So I can do now whatever I want. So for example, I can try to create some summary of the statuses that I downloaded. So for that, very quickly, I'm going to care only about the text column. I'm going to retrieve a sample of 10 random statuses, and I'm going to convert that to a list. So this is going to be my list of statuses. There we go, and I have here a bunch of things. And now I can use the summarizer pipeline to try to extract a summary from this. For that, I will need to craft a prompt. So I'm going to do something like this. So I'm going to format this with all the statuses. So this is going to be a format of status of the list of statuses. There we go. I need to write properly. This is my short prompt. And I'm going to add a sentence at the beginning to help the model. So this is a list of posts by Luis Villa. And I'm going to print it just to see that everything works. So short prompt, there we go. And now I can use my summarizer on the short prompt. So this is going to give me some results. I'm going to give it a moment to finish. And then you see, I finally have the summary that I want. So if I extract that, then I have my summary text, and I can already see that this is already much more concise. Not directly responsive to your question, but blah, blah, blah. So this might or might not make sense. That's a topic that we have to consider separately. But at least you can see that all the notebook code that I wrote here is very clean. I'm not including direct paths of any model or any data set and so on. All the heavy lifting is done by the Kedro catalog. And then finally, if I wanted to have that in a pipeline, then I could do something like this. So there's this function that is going to write the executive summary. So essentially doing the same thing that I did right before. And then the pipeline is going to have just one node that takes the clean statuses, the summarizer model, and then optionally a parameter that I included here to limit the length of the input. So to run that pipeline, now I'm going to do Kedro run pipeline reporting, and then this is going to load all the datasets from the catalog, and after a few seconds, execute the pipeline as I just instructed it. There we go. It already loaded the Delta datasets from my Minio storage. It also loaded the transformer pipeline datasets, and now it's executing this function here, and it's going to dump it somewhere safely. And that is it. So now every time that I want to run this summary, I will just have to run this pipeline, and then the results are going to be stored either in Minio or in text form locally or whatever I want. So to go to the conclusions, there's many ways in which I can expand this. This was a trivial use case, but I want to make it more complex. We also want to introduce integrations with vector databases so that we can perform some retrieval augmented generation. We want to demonstrate as well how you can deploy this model using a REST API, and would be nice to have a dashboard or a web UI as well. So I would be very glad to welcome you in the Slack community. I hope you found this interesting, and I will be happy to take any questions. Thanks a lot for watching.
Thank you very much, Juan, for your presentation. And now let's jump to a Q&A session. And I see on the chat the first question to you. Is Kedro suitable if we would like to build interactive data science application using, for example, Streamlit, or is it tailored to data engineering pipelines?
Thanks a lot for the question. Yes, indeed, it's suitable for interactive purposes as well. So there have been lots of people that have built Streamlit dashboards on top of Kedro pipelines. The only thing that you have to do is that your Python backend needs to launch the Kedro pipeline under the hoods. Alternatively, you can have some more complicated architecture, like putting an API in front of Kedro and then using your dashboard to that. But regardless, it's perfectly possible.
Okay, and question from Piotr. Could you please show again slide 13 and highlight what make Kedro unique compared to similar solutions you mentioned?
So this slide with the comparison, I suppose?
That's right.
So in our view, what makes Kedro unique is that it ties different pieces of the puzzle together. So it gives you a standard project structure that is more or less the same for all projects. So onboarding, it's very quick for people that already know Kedro. And we keep it also up to date with modern Python packaging practices and so on. It allows you to do data versioning with a declarative data catalog as well. So it cleanly decouples the execution from the I/O. And then the ecosystem of connectors, plugins, and so on brings Kedro to another level. So those would be, for me, my salient points.
Okay, thank you very much, Juan, for your presentation. We are running slightly out of the time, so thank you very much, all of you, for your participation in this presentation. And as always, you can rate Juan's presentation using stars under the video player. So see you after a few minutes.
Thank you.